And without further ado, I'm going to introduce Royta and Ramu. And they're going to be talking about build RDF Graph SPARQL endpoints with autonomous database. So just a little bit about them. Royta Yamanaka is a regional product manager for Asia Pacific in spatial and graph technologies. He's got 10 years of experience as a consultant and in pre-sales. But really, rather than going through all the dry stuff, I mean, he's got a PhD and he's got all sorts of fancy things. A very clever man. And so, but some interesting things is that he lives in Toyota City. And because of the remoteness of Toyota City, his small city, he calls it, he does a lot of bird watching on weekends. Ramu is newer to our circles, and she's become a product manager at Oracle. She has the auspicious honor of having two surnames, so Ramu Maurakami Gutierrez, and she's very proud of the fact she's got both. And she is actually going to demonstrate her surfing online today. So she's not going to demonstrate for us, but that would be nice. But we might see a picture. So without further ado, let me hand over and happy hunting. I hope it goes well, Ryota and Ramu. Thank you for presenting today.
Thank you, Roger. Let me then take the screen. Okay, can you see my screen now?
Yes, thank you.
Yep. Well, thank you for the introduction. I am Ryota, and my colleague Ramu. We are both from spatial and graph product management team of Oracle. And in this session, we are going to introduce how to build RDF graph SPARQL endpoint using autonomous database, basically for free, because we have Oracle Cloud always free services. Agenda in this session. First of all, I will introduce what is SPARQL endpoint, and also an active SPARQL endpoint as an example. National Statistics Center of Japan is running their own SPARQL endpoint. So I will talk about that briefly. And two different deployment options of Oracle Graph for using RDF and SPARQL. I will do the first demo for RDF server, and Ramu is going to show the second deployment option of the RDF functionality of Oracle Graph, which is Graph Studio. So first, what is SPARQL endpoint? SPARQL is a name of protocol which has 10 years history after it became W3C recommendation, one of the recommendations. When organizations such as DBpedia, which is a clone of Wikipedia, or National Statistics Center of Japan or other countries, sometimes life science institutes, they are publishing their own data for collaborating with other institutes. And media companies such as BBC, they are also publishing data on the internet. And other governmental organizations such as national libraries, they are trying to create more and more public information on the web. And they are trying to connect and link them each others. To do that, they have the standard for the data format, which is called RDF, Resource Description Framework. And there's another standard for querying against that web of data, which is called SPARQL. Well, SPARQL is a combination of query language and its protocol. So for those people who are interested in the open data, if they can learn SPARQL, those people and applications can access to the web of data to get the latest open data. As an example, our customer, National Statistics Center, Japan, they are publishing national statistical data in LOD, linked open data. They provide a SPARQL endpoint like this. This is a web screen of that endpoint. The people can write SPARQL query here to get the result on the screen. At the same time, they can run SPARQL queries using REST API to get the result in JSON. The data set is growing. We can count the volume of the data set using the number of triples, which is just like the number of rows of relational tables. And their RDF triples have been increased since 2016 when they have started publishing RDF data using Oracle database. And more users and applications are using the data set via this SPARQL endpoint. That organization or other national organization, their aim to publish the data in this format, having that SPARQL endpoint, is that they would like to incubate more and more citizen scientists using the endpoint and making the open data more variable. They create web application to visualize the statistics, and then they analyze the data. For example, this is a website which is created and shared by one officer from a local government. This application can visualize the population of all cities and areas of Japan using this pyramid chart. So from this web interface, we can select the political district and prefectures and city names so that we can visualize the population in this way. So here, here's the number of male, female in 1980, and the age 0 to 100. And once you click this graph, you will see the change during the last 40 years. This visualization is very intuitive, and people can access to the information using this web interface. This web application is executing SPARQL queries against the endpoint of the National Statistics Center. So the people can, should be very much interested in the status of their own cities, and then they can visualize the pyramid chart in this way. So this is just one example of applications that people are creating more and more application on top of the open data with their creativity. Well, going back to this organization, this slide and the following slides are from their presentation in 2020 Analytics and Data Summit in California. You can access to this slide from this link. So let me share this link later on the chat window. They have been publishing their data from 2008, but at that time they are publishing Excel data sheet, and then they started publishing API services using XML, JSON, CSV format. 2016, they started using RDF format, and then they call it linked open data. So they still have Excel and XML data format, but a part of data is published in LOD RDF format. When they are publishing data in Excel or other file format, it is difficult for the user to access to the information by query. And the semantics of those columns of the one particular Excel file is not very clear. So they started using RDF and vocabulary, which is shared in the internet. So in their case, their original data is in database in relational format. So what they could do is convert the data from tables to a semantic graph like this in standardized RDF format with the metadata, so that machines, like applications, can understand the data with semantics. So after publishing the data in RDF format using SPARQL endpoint, users can write SPARQL queries and execute it using REST API to get the result. In the previous application, the queries are getting the populations of each prefecture or cities, but at the same time, they are using geospatial and geo-RDF. So using geospatial, GeoSparkle, we can also get the information such as population for of a particular grid. So that data is expanding. Since the data is expanding, the scalability of the backend database is very important. After they introduced Oracle 18c in 2018, the response time for the SPARQL queries are very stable and fast enough, like 2 seconds average, even for relatively complicated queries. Using Oracle Graph, we have two deployment options. As I said, one is RDF server, which is a separate instance from Oracle database, but we can use all editions of Oracle database. We need to install RDF server and integrate with Oracle database. Then we can load RDF data from a web browser or using any data loaders for Oracle database. It allows REST API access. We can publish the dataset on public RDF, SPARQL endpoint. So the external applications can access to this RDF server. So this is a only option for creating RDF SPARQL endpoint. At the same time, we have new feature, Graph Studio, which is a built-in feature of Autonomous Database. So you don't need any installation. You can load the RDF data using object storage, and you can access and run SPARQL queries on top of notebook. And you can also use different interpreters for Java and Python to manipulate the data. This is the architecture of RDF server. You need to have a separate RDF server which can connect to our Oracle database, and you can access to RDF server using web browser or from applications using REST API. Option 2, Graph Studio. It is a part of Autonomous Database. It is included by default. So no installation needed, and you can access to Graph Studio only from web browser. Okay, let me show RDF server first. The whole demo content, the steps is described in this Medium blog post. So if you are interested in, please follow this blog post to create your own endpoint. The steps are create an autonomous database, create an RDF server using marketplace image, and then load a RDF dataset to the environment, and then run SPARQL queries. Okay, let me show you my environment here. Yeah, this is a blog post, so everything is here. I have one autonomous database, ADB1, and if you log into database actions, you can find that there's one database user called graph user. Then when you need RDF server, you can search for the marketplace image from here, marketplace. So you can find this image and launch stack. So you need to input the name of the stack and name of the instance, availability domain, and shape of the compute instance, public key for SSH, and the network component, and then password for WebLogic administrator. Then once you create this stack, you will get one compute instance like this. So please check the public IP address here and then access. So you will see this window to log into RDF server. This is the interface of RDF server. The first thing to do is to go to the data source tab and create a data source. here, in this case, we need the connection to autonomous database using wallet. So you can upload the wallet, which you can download from the Oracle Cloud Console here. From here, you can download the wallet, right? And I have already downloaded a wallet. So let me use this thing, wallet ADB1. And before uploading this wallet to RDF server, one tricky thing is that we have to include the credential information into this wallet. So to do so, the easiest way is to upload the wallet to the compute instance, then log into the server, then extract the zip file first, and then add this credential information using mkstore command, which is already there on the server. And then input the password for the wallet, and then zip again. So you will get the modified wallet, which include the credential information to log in as the user, graph user. Download the modified wallet from the server. So now you've got this wallet with credential zip. Let's upload this here and name this as ADB1 graph user 2 because I have already created ADB1 graph user. You can choose any wallet service. Now we have created the connection to the autonomous database. Then let's go to this data tab. You will see data sources. These two are actually the same because we are connecting, these are connecting to the same database with same user. Let's pick ADB1 graph user I have already created, and then create RDF network. RDF network is a logical graph where we can add all the RDF triples. So let's name as RDF network and select any table space available. So the network is going to be created. And then once you've got RDF network, you can load the RDF data. To import the existing RDF data, go to this import tab and load the data from files in this case. You can get a sample triple data from here. It might take some time for downloading the data, but I have already downloaded this here, movie stream RDF.nt and triples. So you can drag and drop the data to this window. And it takes some time for uploading data. let's just skip this process because it might take some time. Oh, it's already uploaded. Then you can load the data into the staging table first, and then it's already in the staging table. So let me just skip here for demo. Once you have loaded the data into the staging table, now you can create a model. A model is a logical chunk of RDF data on RDF network. So this is a logical partition of the set of RDF data. And you can create a movie stream model, in this case, from the staging table. We have already loaded the triples, okay? Then after loading the data, you will see the model here, movie stream. Double click this model, and let's execute this simple query first. This is the example of triples. Triples have 3 columns, and they are called as subject, predicate, and object. Subject, this is one movie, which is represented as URI. URI is used as an global identifier of resources in RDF world. And this movie has object, expecting love. Its title is expecting love. And this relationship title is also represented as URI. You can see that this RDF network includes a lot of RDF triples, right? And SPARQL is basically a query language to do pattern matching against the huge triple data set. Let's see several SPARQL query examples. This is one example. This query is for retrieving the title and revenue of movies where Kevin Bacon has acted, right? So we've got the list of movie titles, and their revenue, okay? The second example is a little more complex. Jack Nicholson has acted for this movie, and we would like to get the title and award name of the movie, but maybe not all movies have got award. So award name is actually optional in this query. And you can order by the result just as SQL. You've got the titles and award names. If you go to the second page, there are some movie titles which do not have award names because it's optional. Third example, this ask query is to check if there's any pattern like this movie such as an actor, Danny DeVito, and the John is action. And it is true because there's one or more movies which has Danny DeVito and action movies. Okay, the last example. This is for describing one particular director, which was a director of the movie Toy Story. So this is for retrieving all related information of this for this resource. So it might sometimes take time. Okay, maybe I can show you the result later. Maybe this director is related to many movies. So in that case, the query takes some time. So that blog post guides all the steps in details. And in upcoming blog post, we will cover how to publish RDF models and how to run SPARQL queries via REST API, so that you can use that for building your own application, semantic web application, incorporate with SPARQL endpoints. So for more information, please follow our blog in Medium, and also we always share the latest information, new blog posts using LinkedIn group and Twitter. So let me share these links later on the chat, and please follow the latest information. The second part of the demo is about Graph Studio. Let me switch to Ramu. Ramu, can you take the screen?
Yes. Hi, everyone. So before I start, I actually wanted to share with you where I started surfing this winter. It's actually in the Canary Islands.
Oh, cool.
I know there's someone from Spain in here, but I was basically born and raised in the Canary Islands, in Gran Canaria to be specific, and this is where I started surfing this winter. So fun fact about that, but let's start with the fun stuff, right?
Thanks for doing that.
Of course. So I'm very excited to introduce Graph Studio and the new feature that we support, that is RDF support for Graph Studio. And I'm going to start by logging into my autonomous database and clicking on Tools. And then under Tools, we have Graph Studio. We will click on Open Graph Studio, and we'll use our username and password. Pretty straightforward. Oh. Give me a second. This always happens in presentations. Okay, so we are signed into Graph Studio, and we have our Get Started page in here. We're gonna go ahead and click on the graph menu and select our graph type. In this case, we're using RDF. And we'll be able to see the graph that Royta created under RDF server, right? So this is a really cool feature of the Converge database, right? Whatever you create in the database, you can access it in other applications. So as you can see here, we have our RDF triple file. But let's say that we wanted to create our graph under Graph Studio. We would just go ahead and click on Create. And then we would copy our bucket store URI, and this would contain our RDF triple file. We can go ahead and click on No Credentials, since this bucket store is pre-authenticated. And we can go ahead and click next and give our graph a name and click on create finally, right? Since this graph is already created, we don't have to go ahead and click on create, but I'll move into the notebook feature of Graph Studio. So let's say that we wanted to create a notebook. We can click on create and give our notebook a name, but I've already created a notebook. So we'll go ahead and click on introduce SPARQL. So in here, we basically have the same queries that Royta just ran in RDF server. But a couple of cool features of the notebook is that we have different interpreters, right? So we have the RDF paragraph interpreter, we have Python, SQL, PGQL, that is the property graph language, and we have Java. So Python and Java can be used with the property graph feature, right? And let's say that we were to click on one of these interpreters, for example, the RDF interpreter. It basically gives us a simple syntax for us to get started quickly on our querying, right? But I've already created a couple of queries, right? The ones that Royta ran already. And we can go ahead and see how they run in the notebook feature. So we would just click on run paragraph, and we'll be able to visualize the same queries that Royta just ran. And the biggest difference is basically that the RDF server uses SPARQL endpoint compared to Spatial Studio that is using the notebook feature, right? So this basically brings me to the end of the demo for Graph Studio. And please, if you have any questions, post them in the QA. And we also have a live lab available where you can start from zero. So you can start by creating your autonomous database, creating your user, and then running some queries. So I'll definitely be posting that link in the chat for you to try it out. Thank you so much for being here.
Any questions? Royta, do you have anything else to share to close this session as we wait for questions to come in?
Well, let me share the links to list all the Medium blog posts and yep.
If you're going to share them on screen, yeah, okay, you're putting them in chat. Great, okay.
Sure.
So I had a question. I think from what you, kind of more like a comment, I guess. So from what I understood from the SPARQL endpoint and so on, it appears that you can expose the data that you have in your database via this publicly accessible endpoint. And you can then combine that with other data sources that also have a publicly accessible endpoint, like DBpedia.
Right.
You could take your movie stream data and perhaps your DBpedia data and then run queries across the two data sources. Is that right?
Right. That's a very good question, because RDF provider, the open data, linked open data providers, they are trying to link the data, the RDF resources, each other's, which means they are trying to use the same semantics, following the existing semantics, which is published by others. So once they are sharing those resource names, like global identifiers, and also the semantics, we can use the same SPARQL query for retrieving the data from different data sources, like SPARQL endpoint. And we can also use a federated query to combine the query result as result of one SPARQL query.
Right.
So the data provider is trying to make the data set connected. So the users can actually do that in the future.
Right, and that's the promise of linked open data. And I see a couple of questions coming through the Q&A. And one question from Martin was, can you do updates on autonomous database? Royta, would you like to answer?
Oh, does it mean is it updates by SPARQL query?
I guess we could answer this. Oh, I guess he's saying yes, it's by SPARQL query. I just want, yeah.
Yeah,
Right.
but SPARQL update is not really, well, the using SPARQL update is not really common for managing data, but well, many customers are using relational database as a backend and mapping from relational to RDF. In that sense, it's great to have a converged database which can accept SQL update and SPARQL update both.
Right. And to add to that, yeah, you can, right, like Royta said, it's maybe not that common, but we do support it in RDF server, and supporting it in Graph Studio is on our roadmap to support SPARQL update on Graph Studio. That should be coming quite soon. So there's another question from Tom. What mechanism do you use to map the results of SPARQL queries to vertices and edges so that they can be visualized as a graph? Is there support for a situation when you have multiple edges connecting the same two vertices?
Yes, it is supported. Multiple edges with different predicate can often exist. So they are visualized as two edges or more edges between the same pair of nodes.
Right. And to respect, sorry, go ahead.
Yes, please.
The first part of the query was, how can you visualize the result of SPARQL queries? How are they mapped to vertices and edges in a graph? So
well, well, for visualizing the result as a graph, you can retrieve the SPARQL query result as JSON, and many people are actually making their own visualization to construct the result set as a graph.
right.
And
also, I believe with the results of a SPARQL queries are triples, and the triples naturally form a graph with the, I believe, subject and object forming vertices and the predicate forming the edge. And I think you can build out your graph that way from triples. And I believe something like that happens under the scenes when you queried, and when Ramu showed a query and then you're showing the resulting graph. I think that's what happened.
So mainly in Royta, the answer here is that the result of a SPARQL query, there are certain supported formats that are defined and known. So you can, JSON is one example, as you all said, and those are defined. And as long as you return in one of those standard formats, which is what we do, another client can take and visualize it. So it's a documented standard format. It's up to the client to interpret based on the way in which they ask for the result. So they can ask for it as CSV, they can ask for it as JSON, and a few other formats.
So Tom has a follow-up question on, well, SPARQL is not always triples. So I hope what Jayanth's comment partly answered your question, Tom, as to, so basically we can consume any
and that's
standard format.
why, in fact, as when Ramu was demonstrating, sometimes the result is just a table, because you may only request scalar values from that SPARQL query. Sometimes you might get a quad back because you're getting an assertion. Sometimes you may get other things back. All that is valid. The point is that the result format is known, it's standardized, and it's up to the client to then handle how that's displayed. And
So
yes,
the,
indeed, you can request many columns, and therefore you can show them as a table.
right. So then there's a question on, is there any limit to the amount of information that can be handled by ADB Graph Studio Notebook for RDF functionality? No, it just depends on the sizing of your database. As long as you're you have enough space in your database, you should be able to handle that, handle any size query. And the reason I'm jumping in and answering is that I will be talking about a performance enhancement that has come in with RDF graphs, which is available with Autonomous Database. So yeah, any large graph should be fine. So Tom is just figuring out, adding a particular comment on that. Yes, Tom, we would love to discuss this with you more offline. So please do reach out to one of us. We can have a discussion on this, because I think that is a critical question. How do you map your query results to tools that you're working with? So please do reach out to us offline. Any
Sorry,
other
I had to
questions?
dash off, Melly. I'm back. What an awful timing, but did we answer all the questions?
I hope so. I think so.
Great.
Oh, and then just to reiterate one thing, there were some licensing questions. I just wanted to reiterate that all the RDF graph features are available with any database license, any edition. RDF server, which Royta showed us downloading from the OCI marketplace, that is also included with any database license. And if you're installing this on premises, we have this as a downloadable and installable component for on-premises installations as well. For RDF server, that is. Graph Studio is a feature of Autonomous Database, so that is with Autonomous Database. So any other questions, thought? Let me check the Q&A box again.
I think Martin Voss was just asking a question, but Ryota's busy answering him now.
Yep. Well, REST API. How we can create a REST endpoint. Well, RDF server can accept queries via REST API once you publish the dataset, the model of the RDF graph. Well, so this functionality, REST server functionality is by default. It's built in of RDF server.
Okay, superb. Francisca Alvarez also asking a question. Is Property Graph RDF also available for the XE edition?
Yeah, it is. Ryota, would you like to add further? Yeah, it is.
Yes.
Okay. All right. So we're nearly at time. If there's any other questions. Oh, there will. There's Francisca's also
Asking, is there any limit on the amount of information that can be handled? Well, no, just as long as Ramu is typing anyway. As long as you have the space and that's covered by your ADB license, you're good.